Hello everyone, my name is Abhishek and welcome back to my channel. So today is the very first episode of our DevSecOps Zero to Hero series, and in this video we will focus on Introduction to DevSecOps. Towards the end of this video, you will learn how to generate a very detailed security report for your application. And this security report can be downloaded as a PDF and it contains all the vulnerabilities related to your application. The demo is going to be super exciting. Now, before we get started, just like any of our Zero to Hero series, even for this series, I created a GitHub repository. So after watching the video, you can head to the GitHub repository and follow the notes for the episode. Make sure you do it, especially when you want to implement the demo, because the notes is going to be very detailed and it will help you as a revision material. Perfect. Now let's get started. Because this is a very first episode, let's start with what is DevSecOps and why is it important? Unfortunately, this is one of the most misunderstood terms in the industry. A lot of people think DevSecOps is completely different from DevOps. In fact, some people think they are two different roles in the companies. Let me tell you, this is not true. DevSecOps is nothing but DevOps with security mindset. In a nutshell, DevOps engineers who think of security in every activity that they perform is basically a DevSecOps engineer. That's it. Now you might have a question. In that case, why DevSecOps, the term coined, and why it became popular? Simple reason. Previously, in the initial days of DevOps engineers focused on their activities like CI/CD, Kubernetes, infrastructure as code, but they did not focus a lot on the security while dealing with these tasks. Now, this created new challenges for the organizations. Organizations started seeing security issues with respect to their infra. Now, this is why organizations push DevOps engineers to think of security. And because of this emphasis, DevSecOps coined as a term. DevOps with security mindset. This is the backstory. End of the day, any DevOps engineer taking care of security, thinking of security while performing their role is a DevSecOps engineer. Now that this is clear, let's talk about the scope of DevSecOps. Again, a lot of people think DevSecOps is scope to CI/CD. This is not true. I have personally seen companies who just added 2 to 3 stages to their CI/CD pipelines and call it as DevSecOps. But in fact, the scope of DevSecOps is very huge. We will do one thing. Let's list down common DevOps activities and let's see how a DevSecOps engineer can introduce security to those activities. We will start with Git. DevOps engineers spend a lot of time with Git. Infrastructure as code, scripting. It can be through shell scripting. It can be through Python scripting to automate day-to-day activities. Containers. When dealing with microservices, DevOps engineers spend almost their entire day with containers, creating images, pushing the images, pulling the images. Kubernetes and common activities like CI/CD. So these are some very popular activities. Let's go one by one. When a DevOps engineer is working with Git, you might ask, what is security aspect with respect to Git? The tasks are very common: to create a repo, to create a branch, to create a branching strategy. Where does security come into picture? Now, this is where a good DevSecOps engineer or DevOps engineer with security mindset would introduce things like pre-commit hooks. What exactly is this? Now, when working with Git, developers can accidentally push their PEM files. Developers can accidentally commit their files like encoded passwords. This can be eliminated if a DevSecOps engineer introduce something like pre-commit hook. Whenever a commit is created, whenever a commit is pushed, this pre-commit hook validates if there is any sensitive information. Only if there is no sensitive information, the commit is pushed to the Git. On top of that, a DevSecOps engineer can also introduce strict RBAC to Git, like ensuring only the right people can read the repo, only the right people can make changes to the repo and administrate the repo. Let's talk about IAC. Now, on day-to-day basis, DevOps engineers work with IAC tools like Terraform. And while using Terraform, they create infrastructure on the cloud provider. Now, a DevSecOps engineer or DevOps engineer with security mindset, whenever they install platforms like Terraform, they would set up secret management solutions like Vault, so that any sensitive information in Terraform, like cloud provider credentials, can be stored to Vault. Even PEM files or secret files, they can also be stored in the Vault secret management. Scripting. Now, this is where things get interesting. Lot of DevOps engineers, they don't care of security while writing the scripts. Let's take example of Python. Now, you might ask what to do with Python. A good DevSecOps engineer would not randomly use any version of the Python packages. If they want to use Flask, instead of using the Flask version suggested by ChatGPT or Flask version that is available on the internet, DevSecOps engineer would look at no vulnerabilities Python package. Let's say there are two versions of Python Flask, 2.3.5, 2.3.6. ChatGPT recommends this version, but DevSecOps engineer goes to the vulnerability database, or these days, companies also have their checklist. Companies also provide the list of packages that employees can use. So they would go there, see that, okay, this is a vulnerable version. So let me use 2.3.6. Containers. There is so much to do with respect to container security. As simple as, while writing a Docker file, a DevSecOps engineer would not run the container with a root user. So in the Docker file, they would not use root user. A good DevSecOps engineer would go with distroless images. A good DevSecOps engineer would go with multi-stage builds, so that the build size is small and even the end package or the end container has less number of packages. Kubernetes. Let's take one example here. A normal DevOps engineer would set up Kubernetes cluster. They would go for EKS and maybe set up the cluster. But a DevSecOps engineer would first set up virtual private cloud, then set up private subnet, and within that, they would set up the Kubernetes cluster so that the nodes of the Kubernetes cluster and entire Kubernetes cluster is secure. On top of that, they would set up secrets management solution in Kubernetes and other best practices. CI/CD, this is where a lot of people start their journey with DevSecOps. That is unfortunate. They should not do it. But yeah, anyways, people start with DevSecOps in CI/CD. So it's very popular. They would introduce stages here, right? Multiple stages like static code analysis, stages like SAST, stages like container security, using platforms like Trivy, platforms like Snyk, or even Docker today supports a lot of security related to containers. So this way, the scope of DevSecOps is not limited to CI/CD, but every activity that DevOps engineer performs. Now you might have seen me interchanging the term. Sometimes I must be calling DevOps, sometimes I might be calling DevSecOps. To be honest, I don't see the difference. I personally feel every DevOps engineer should be a DevSecOps engineer. Every DevOps engineer should think of security right from the point they start the project. This is what DevSecOps also says. One of the fundamental principle of DevSecOps is shift left principle. What is shift left? Every organization has 2 points, the left point and the right point. Left point is where the application development starts, and right point is where application is deployed to the production. Earlier, in the previous days, this is where security was considered. Once the application is deployed to production, DevOps engineers used to think of the security. Maybe if the application is deployed to Kubernetes, at this point, DevOps engineers used to think of API gateway. At this point, they used to think of securing the Kubernetes cluster or adding any best practices to Kubernetes. The shift left principle says, just like how application development starts at the left point, just like how DevOps engineers start creating infra at the beginning of the project, just like how they create Git repository at the beginning of the project, how they create Kubernetes cluster here, in the same way, they should also think about security at the left. So this is called shield right approach, the very wrong approach which was used in the past. This is called as shift left approach. By shifting security to the left, organizations can benefit. Very, very simple, right? When companies create Kubernetes cluster, at the point, they have to create a secure cluster. When they install Terraform, they should install Terraform with Vault. When they create GitHub repository, they should create pre-commit hooks while they create the repo. This is the shift left principle. Now, while we talk about all of this, some of you might have this question, Abhishek, do I really need to upskill in 2026? Because people keep saying in 2026, AI will take over all the jobs. So what's the point of learning DevSecOps? Let me tell you, DevSecOps is one skill that has reverse effect on AI. That means as AI keeps scaling, as companies start using more and more AI, DevSecOps adoption will only keep increasing. Why? Today, AI is writing most of the code. If you look at companies, in majority of the companies, 60% code is written by AI, the latest code, and 40% code is written by the developers. In some companies, 80% code is written by the AI itself, like ChatGPT or any inbuilt models that are supported by the organizations. Now, what happens with AI? Of course, it writes the best code, but a lot of times it uses outdated packages. Lot of times it uses the package that is not supported by your company or which is against the compliance of your company. A lot of times AI copies the code from other sources, like it is inspired by the code that is in Stack Overflow, or it is inspired by the code that is in the Reddit, and it might provide you the code that is working, but a buggy code, a code that has lot of vulnerabilities. Now, how will you overcome this situation? You might say, but Abhishek, developers are still in the loop. Developers are still reviewing the code that is written by AI. Yes, they are doing it, but developers mostly review the code to see if the code is working. They test the code locally, they see the flow of the code. They might not look at outdated packages, they might not see the complaints, or they might oversee the buggy code. This can be eliminated by DevSecOps. What organizations can do, they can counter the bugs introduced by AI by building strong DevSecOps pipelines. One easy use case, strong CI/CD pipelines, which can potentially look at all of these bugs. Tools in the CI/CD pipelines, something like, we learned about Quiet in the past. there is a video on the channel. Quiet is something that can identify AI related issues. If possible, we will look at Quiet even in this series as well. Or maybe use tools like Snyk. Use container security platforms like Trivi. It can tell you during the runtime if your organization will be impacted by any outdated package. It will scan the vulnerability database and it will tell you any issues with the packages. So this way, DevSecOps has a counter effect on the AI or anti effect on the AI. Okay, we learned about the what, the why, and the good and bad of DevSecOps. Now let's see how to start with DevSecOps. Okay, Abhishek. Now I will learn DevSecOps, but once I join the company, how it would look like? What would be my first step? There are two possibilities here. The first possibility, you would work in a company which is a startup, and let's say they don't have any DevOps culture there. The other possibility, you would go to a company which is a legacy company, and in the legacy company, they have the DevOps workflows in place. And mostly, they will be reluctant in following any new practices. Legacy companies, they have DevOps practices. Sometimes they have security issues in the practices, but still, if it is working, they would be hesitant in upgrading the practices, especially MNCs. So this is one possibility, and this is the other possibility. If this is the possibility, you are lucky enough because you will start the DevOps in the company and you will take care of all the best security practices. But what if you will go to a company with all the legacy pipelines, all the legacy DevOps tools, and it might have some buggy code as well as buggy infrastructure? How will you convince your company to onboard DevSecOps practices? So this is where you have to implement threat modeling. Now I'll show you how to use threat modeling and how to generate a security report for your existing infrastructure as well as your applications. So that way you can share this PDF with your management. You can share this PDF with your development team, and you can set up a meeting and discuss the existing infrastructure might lead us to potential issues. So let's onboard DevSecOps practices. What is threat modeling? No, it's a process where you identify the issues. It's a process where you analyze the issue and potentially you also mitigate the issues, right? That is what we will see now. So for that, there are good number of tools in the market, but most of the tools are commercial licensed. What we will do in this lecture, we will go with OWASP Threat Detector or OWASP Threat Dragon. So OWASP Threat Dragon is completely open source. You can do your proof of concept. What you can do, you can paste your or you can draw your architecture diagram of your infrastructure within Threat Dragon, and it will show you all the possible issues. It will give you a PDF report with all the bugs that are related to your infrastructure, typically vulnerabilities. It's going to be super interesting. What you have to do, you have to first download this. So go to OWASP Threat Dragon, click on the download installers button and install Threat Dragon on your laptop. Now I already have it. I used it in the past. So I'll search for Threat Dragon. There you go. So this is the Threat Dragon interface. Now let's start with creating our architecture diagram. Let's go with create a new empty threat model. I'll do it from the scratch. Let's do it for a simple two-tier web application. Two-tier web app. Owner Abhishek, reviewer is Veeramalla. I leave these options default and I will provide a diagram. So click on add a new diagram, save the record. A JSON file will be saved to your local machine. Just save it. Okay, close this and you will have an option to draw the diagram. Don't worry, you don't have to be good at drawing the diagram. You just have to explain the Threat Dragon, how your application flow looks like. It will take care of everything. So let's say we have a simple two-tier architecture, right? Where we have a web application and that web application connects to the database. So your company, what did they do? So every time a user, so I change the property here, scroll down, you can also do it. So actor, I said a user does not provide any authentication and this user talks to a web application. Okay, so I'll take there are only few components here. One is the process component, actor component, the data stores component and data flow component. That's it. Using these four components, you can draw any architecture diagram. Now process, again, I'll change the property. I'll call this as a web application. There is an option for web application. Tick this. It will ask you a few questions. What is the privilege level? Let's leave it default. Is this web application related to card payment? Leave it default. Goods and services? Leave it default. Okay. Finally, a database. For that, I will take the store option and put that here. Again, I'll change the property. So I'll call this as MongoDB. Okay. Let's say my web application talks to MongoDB. And it stores the inventory. There are a few questions here. Does it store any credentials? Let's say yes. Is it encrypted database? Let's say no. Does it store a log? Let's say no. That's all. We will provide this piece of information and we will say these components are connected. How? Let's take the data flow, connect user to the web application, connect web application to the database. And then let's say using this trust boundary that user is on the internet. So there is a boundary between user and the web application. Okay. So user is from the internet and these things are within the internal network. Of course, I did not put them in the same network, but it's fine. For our simple diagram, user is on the internet, web application talks to the MongoDB. Now you might say, Abhishek, everything is looking fine. What is the issue with this architecture? Let's see what OWASP Threat Dragon says. Save this. Okay. Now just scroll down. Once you save it, just scroll down, select the particular component. Okay, I'll just close it, open it again. I'll select MongoDB component and click on new thread by context. There you go. So it says there is information disclosure vulnerability on your database because you did not detect any fake or compromised accounts. You did not ensure information is accessible only with authentication and authorization. It's true. In the architecture diagram, my web application is connecting to MongoDB. I did not provide any authentication, or the architecture diagram does not say there is any authentication that is set up. Okay, let's see what are the other vulnerabilities. This is one. I applied it. It says there is another vulnerability, elevation of privileges. There is another vulnerability for information disclosure where you did not stop any denial of service attack. Now there can be n number of attacks on the database. Further, and further. So you can see there are 8 different bugs that are identified on my database. Instantly on the architecture diagram, MongoDB became red. Now these are not ordinary bugs. Like you might say, Abhishek, these are some random bugs that are generated by Threat Dragon. My organization would ask for the explanation. That's good. Just go to any of this. Like if you go to scraping, so you can see this is OWASP automated threat 11. What does it say? If you go to the internet and if you search for OWASP automated threat 11, there is a complete information. You can share this information with your developer. You can share this information with your security expert, anyone who asks. Just share them. This is the definition of the vulnerability. This is the description. And this is how we can mitigate the issue. That's all. Similarly, for all the tools, enough information is provided. Let's go back to Threat Dragon. You can see all the 8 threads here. And you can work as a team. Once you all agree, like let's say your development and you agree that, okay, this is not a potential threat for us, you can open it and you can change this as mitigated. Change this to mitigated, say the severity as low, and if you want, you can delete it, or if you want, you can just apply it. So you can see this is changed to green, just like Jira. You can work as a team. So over the next few weeks, you can complete all the other issues as well. Now, not only on database, you can see some issues on the web application as well. So if you click on web app, click on new thread by context, you can see there is tampering issue on the web application. There is information disclosure issue, elevation of privileges issue. Again, another information disclosure issue. 4 vulnerabilities on the web application as well. That's why web app also turned to red. But Abhishek, how will I share all this information to my team? Right now, they don't have access to Threat Dragon on my local machine. Don't worry. Save this, close, and you can extract the report as well. Once you click on the report, you can see the detailed report, a PDF file that is generated by Threat Dragon. It says, okay, overall, there are 12 threats on your application. 1 threat is mitigated, which we closed. You have 0 critical vulnerabilities, but you have to be decided severity. That is, you have to work with your development team to decide the criticality. This is the architecture diagram that you provided. These are the vulnerabilities on the web application. These are the vulnerabilities on the MongoDB database. A complete security report is provided. Perfect. Now, what about dealing with more complex applications? You can deal with any complex application. In fact, what Threat Dragon does the best, it provides you some sample threat models. If you want to learn how to draw the architecture diagram, if you want to see how detailed the report is going to be, just go to the examples. Let's use one. So we have here online game. Click on it. You can see a complex online game. Okay, I'll just decrease the size here. This is the complete architecture. So you have the player's local station, you have the production network and the corporate network. A well-defined architecture diagram. Usually this looks like everything is perfect. But again, if you go to the player's database, you can see OWASP Threat Dragon says there are multiple issues with this architecture. 1 issue, second, third, 3 issues on the player database. Similarly, on the stats database, again, there are some issues. Now, it does not confirm these issues are not mitigated by your company, but it says, at least by the architecture diagram, you did not solve these issues. If you think you solved it outside the architecture, you solved it within your source code, just come here and close the bug, mitigate the issue. And once everything is done, save this. You can save it and you can generate a detailed report. Right? Again, the same way, you can see the architecture diagram and you can see the bugs. Because I did not save the bugs, right now it says there are no issues. Otherwise, just save all the bugs. You can get the detailed report as well. So this is about threat modeling. One thing which might be too early at this point of time, but just to tell you, in threat modeling, There are different frameworks that can be used. OWASP Threat Dragon use a framework called Stride, STRIDE. So this is a framework that is created by Microsoft, and internally, Threat Dragon uses this framework basically to identify issues on your architecture. I hope you learned something exciting today. You not only learned about the fundamentals of DevSecOps, but you also learned how to threat model your infrastructure and application. Go ahead, try it with your application, try it within your organization, and build a good DevSecOps culture. See you all in the next video. Take care.